Okay, so today we are going to continue with some examples of simplifying trig expressions. So, we're going to be using all the different identities that we learned about last week. So these are the three examples we went over on Friday last week before the weekend, right? So, we treat each one of our trig equations, sine, cosine, tangent, like it's its own separate variable, and then we use our identities to manipulate the equation. And our end goal is to either get it into one trig function, right? So negative sine to the third, that's a lot simpler than this whole thing, right? Or a very simple expression, okay? And usually our end result, we want either sine, cosine, or tangent, okay? But if we can get sine or cosine, those, again, are our most basic trig functions. They're kind of like at the bottom of the pyramid. They help us make the other trig functions, okay? So last week we did a basic one with one of our Pythagorean identities, okay? So that's one method. And we stopped at factoring, right? So, anytime that we factor secant squared minus 1, right, we can split that. That's like saying x squared minus 1. Or we have kind of like a quadratic setup, something squared plus something to the first power plus the constant, right? We can treat that like a normal quadratic, right? We can factor it that way. So the end goal, and this is what we're going to start doing tomorrow, is verifying trig expressions. So they'll give you something. Let me see if I can have an example here. No, that's too far. So they might say something like verify they might say verify that the secant squared minus 1 over secant squared equals sine squared, right? So they want us to get from this picture to this picture. So we would use a whole bunch of different rules. We would use, maybe our reciprocal rules or our quotient rules or our Pythagorean rules, right? So before we get to that, though, I want to make sure that you guys see all the different ways we can manipulate, right? So we are going to pick back up with some factoring. But this one's going to be a little different. Oops, forgot how to spell simplify. Now, again, you may see a bunch of different variables following the trig functions, right? We have theta, we have x, we have t sometimes, we have omega, the w. Just treat them. If you want to replace them with a variable you're more comfortable with, go ahead, right? But they all just mean the same thing. Okay, so here we want to simplify cosecant squared minus cotangent minus 3. So the last one we saw, right, they were both the same. And then that's simple because then we can just use our normal quadratic rules, right? But there's no way that I can multiply two cosecants together to get a cotangent, right? I can't split this, say like, I can't do this, right? That's not going to work because I have a cotangent there in the middle, right? So all this is garbage. I can't do any of this. So we need to have one trig function, okay, or either I want everything in cosecant or I want everything in cotangent. Well, one of the things I think about, well, what relationships do I know, if any, that relate cosecant and cotangent together? Okay, are there any of my functions? Well, it's not going to be a reciprocal function. They're not reciprocals of each other. Okay, it's not a quotient because cotangent has cosine and sine. But if I look at the Pythagorean identities, I have that 1 plus cotangent squared equals cosecant squared. Okay, so, I put that, off to the side. I remember that equation. 1 plus cotangent squared equals cosecant squared. Okay, so now we have to figure out which one we're going to manipulate. Well, this cotangent I can't touch because it's cotangent squared. Okay, so I'm not going to touch this because I can't just add a squared there. That doesn't, there's no way to balance that out. I can't take the square root of everything, so that's not going to work. So let me see if I can replace this cosecant. Well, cosecant squared, if I want to get this alone, okay, I can rewrite my Pythagorean identity that cosecant squared is equal to cotangent squared minus 1 if I subtract this. All right, so now this is what I'm going to substitute in for there, and then we'll be dealing with only cotangents. So for now, I'm going to put it in parentheses. So again, I'm replacing cosecant squared with cotangent squared minus 1. And then I have minus cotangent minus 3. And now I am going to go through my steps of simplifying. I have a -1 and a -3. So I get cotangent squared. Wait, did I do something wrong? I think I did something wrong. Give me a second, I apologize. 1 plus cotangent squared equals cosecant squared. Oh, I switched these around. My apologies. I said one thing, then I wrote another. So we actually don't have to change any of that around, and this is just going to be plus. Okay, so my mistake. So cosecant squared is equal to 1 plus cotangent squared. So right away, I just can substitute. We don't have to do any manipulation. Did I tell you the wrong thing then? Back here. No, I just wrote it wrong. Okay, my apologies. Okay, so that's plus 1. So then we have the cotangent squared minus cotangent, and then plus 1 and a -3 gets me minus 2. All right, so now we're back to a quadratic form. Okay, it's not an exact quadratic because it's not just x squared minus x. But we can treat it like, y squared minus y minus 2. So I'm going to split it up. So I have a cotangent x over here and a cotangent x over here. And the only numbers that multiply to 2 are 2 and 1. And This is negative, so one has to be positive, one has to be negative. This is negative, so the 2 is negative and the 1 is positive. All right, so I'm going to write this again. You don't have to write this. Once you have the simplification, right, you can just circle it or write it in as your answer. But I'm just going to rewrite cosecant squared x minus cotangent x minus 3 is the same thing as cotangent x minus 2 times cotangent x plus 1.
I'm confused.
What's up? Where'd I lose you?
So from the Pythagorean, right? From 1 plus cotangent squared x equals cosecant. What happened to the cosecant?
So, okay. So I used this rule to get rid of this cosecant. So I replaced this cosecant squared, right? I used substitution, and I plugged this phrase in for that part. Because the reason we did that was because this is a cotangent, and I have, I can't do anything with just a cosecant squared minus cotangent. If I left it like that, I couldn't simplify it any further. So I changed it. We have a rule where we can change cosecant to cotangent, or more specifically, cosecant squared to cotangent squared plus 1. So I substituted that in, and then I just messed around with the cotangents.
Got it. Thanks.
Okay. Yeah, no problem. All right. So let's look at one where we're not factoring, because that's, that is a type, but it's not a super common type. Okay. So here they want us to simplify as much as possible. So I have the sine of theta plus cotangent cosine theta. So right off the bat, there's not a whole lot to work with. We don't see any squares, so we're not going to use any Pythagorean identities. Okay, the only time you use Pythagorean identities is if you see anything squared, right? Sine, cosine. Actually, we have rules for all 6 functions. Okay, excuse me. So no squares, no Pythagorean identities. So the one rule that I told you, or the one hint I told you last week too, was to try to, if you don't see anything right away, try to get everything in terms of sine and cosine, because those are our most basic, and they'll, things will work out if we can get it looking like that. So this sine is just sine. I can't do anything with that. But we have the rule that cotangent is cosine over sine. All right, so now I have that rule that I can change this cotangent to a cosine over sine. Okay, so we have sine plus cosine over sine times cosine. Now we're going to go through steps and just start simplifying, start making it look a little nicer. So I'm going to multiply these two together. Right? Anytime I multiply a fraction by a non-fraction, right, we can always put it over 1. So right now I'm not touching this sign. Now this, because I'm multiplying 2 cosines in the numerator, that's going to become cosine squared. And in the denominator, sine times 1 is sine. Right, so that first step, there's really nothing else you can do. Sometimes you're kind of pinholed into doing one thing. Right? I couldn't really do anything else with this combination that I have here. But now I have sine plus cosine squared over sine. There's a few different ways I can tackle this. All right, we have a cosine squared, so I might be able to use Pythagorean, but I don't want to be plugging in. I don't want to be manipulating and plugging in if I have to. So we are adding two terms together, and one of them is a fraction. What do we normally need when we're adding fractions together? We need a common denominator. All right. So what I do, well, this one, I don't have to multiply anything, but this one, I'm going to multiply the top and bottom by sine. So sine times sine gives me sine squared over sine times 1, which is sine. And here, I didn't do anything to this, so I'm just going to rewrite this cosine squared over sine. Now that they have the same denominator, right, we treat it like a normal fraction. I combine the top. I combine the numerator, sine squared plus cosine squared. And now this is real simple. Anytime you see a sine squared plus cosine squared, we replace it with a 1. That's real nice. That's real easy. So I have 1 over, let me make that look a little nicer. I'm getting a little sloppy with my thetas. So I have 1 over sine theta. So that's pretty simplified, right? And it's in terms of sine. But I could take it a step further. And I can use the reciprocal rule. And say that sine plus cotangent cosine is the same thing as cosecant. Okay, so one thing that I will, say if you're kind of unfamiliar, or not unfamiliar, but if you haven't had practice in a while with adding fractions, okay, with variables, I'd practice some of that because that could be a good help. All right, let's do one more.
Wait.
So while you're copying this, I will say with one thing with this part that we're doing now, you are at a slight disadvantage because you really don't have an end game. They just say simplify. And with these, okay, there's multiple ways I can do it. Right here, I could have changed this to 1 minus sine squared and then dealt with it that way. Okay, so like they say, there's more than one way to skin a cat, right? There's more than one method to get from point A to point B. Now, with what we're going to move on to tomorrow and Wednesday, it's going to be a lot easier. Not a lot easier, but it'll be simpler because you have an end game, right? I know I want to manipulate this. I want to simplify this, but I'm not just going to simplify this to anything. I want to simplify this to this. Right? So here, okay, I need to make sure I work in a sine somewhere. With something like this, it's just saying simplify. So it's kind of like, you're left to do your own thing. So it is a little more difficult now. So if you're kind of a little confused now, it does get simpler tomorrow. Okay, we good with this? Okay. Okay, so our last simplification problem is one where it's something, a common thing in math where we don't want a fractional form. We want to avoid fractions as much as possible, especially with trigonometry. Things get a little complicated. So here we have 1 over 1 plus sine of x. Now, we did something kind of similar to this when we did our imaginary numbers and our complex numbers. A good way to start this is to multiply by the conjugate of your denominator. Right? And whatever we do to the denominator, we have to do to the numerator. Now, the reason I picked this is, well, because once we have a sine squared and a 1, that's a good place to start because we can start using our Pythagorean identities. So here we have a perfect square. So when I multiply these, when I FOIL them, I'm going to end up with 1 minus sine squared x. And in the top, I have 1 minus sine x, right? 1 times that. And then here, the middle terms cancel out. I get a negative sign and a positive sign, and they eliminate each other. So now that I have this, okay, we know that sine squared plus cosine squared equals 1. Well, if I move the sign over, I get that 1 minus sine squared, which is what I see here. I can replace this with a cosine x. I'm sorry, cosine squared x. All right, so it looks a little better, but remember we want it so it's not in fractional form. I don't want any fractions. So when we have this, when we have one term in the denominator and more than one thing up there, we can split it. I can have 1 over cosine squared minus sine over cosine squared. Now this one's somewhat simple. I have 1 over cosine is equal to secant. So 1 over cosine squared is going to give me secant squared. But here I have a slight problem. This is to the first power, and this is squared. So I'm going to rewrite that. I'm going to have sine of x over cosine times 1 over cosine. Right? So, I split this up so that it's 2 separate parts. And now each of these I can replace. I have secant squared x. I just bring that down. Minus, bring that down. Sine over cosine leaves me with tangent. And 1 over cosine leaves me with secant. Okay, and we can even take it a step further. I can factor out a secant. Nope, just a regular secant, not a squared. Okay, but this is fine. That's all I'm asking for, right? It's not in fractional form anymore down here. All right, any questions? So yeah, so you may be thinking this does seem a little tricky because how do I use all my rules? This part is just practice. There's no real method. It's kind of like solving a puzzle, right? You got to follow the clues, right? You got to use what you know. So like I said, if it helps, I know it's a little nerdy, but maybe print out your identities just so you have reference to them. Have them somewhere on your laptop, on a separate piece of paper. Rip it out of your notebook. Make sure no notes are on the backside. All right, just so you can have this for reference. All right, I'm gonna give you one or two problems similar to what we did today, just where you're gonna simplify, and then we'll go over those tomorrow, and we'll pick up with verifying. So the end game for all this. All right, guys. If you don't have any other questions, that's it for us today. Have a good day, and I'll see you tomorrow.
Can you go back real quick so I can finish copying?
Yeah.
Bye, Mr. Murray.
Bye-bye. Just the last problem there?
Yeah, just like the bottom part.
Sure thing. Take your time.